All right, happy Monday again. Got a couple things today. We're moving on to functions. This is one of my absolute favorite topics because functions are amazing um, and super useful, super helpful. There's a lot to them, so we'll do a lot today. We'll have our lab today, and then we'll practice them some more on Wednesday. We're also going to talk about project one on Wednesday. I'll go over the solution, how I might solve it. Again, that's just one approach. There's lots of different ways you can write the code to all do the same thing. That's the fun part of coding. That's the creative part of coding, is you don't all have to do it the same way. Right? We're all just getting the job done. And different people like different kinds of inputs, different people like different kinds of menus. That's all fine. So I think I showed an example of some output of what it might look like when it runs. Did I do that? Yeah, okay, good. I thought I did it for the other class too, and like one person said yes, and everyone else looked really confused. So, sure. So again, I used strings. Some people like, hey, enter 1 for this, 2 for this, 3 for this, 4 for this. That's super easy too. Whatever you prefer, it'll still work, right? No big deal there. Eventually, we can get into building a user interface where people can actually click on buttons and see stuff. We don't get to that for quite some time. I think that it's still in. Oh, did they not put it in here? I thought they had it. They used to have it. Where did it go? Those are labs, material, basic graphics. Okay, so it's in chapter 17. There's this basic graphics section, if you're curious here, which is super cool. So you can finally build a little program at the window here that does some stuff like histograms, really? That's what they gave us? Okay, sure. I like some buttons, but tkinter is a really cool library, and you can build windows that actually like pop up and you can click on. But we have to have all the basic stuff first before any of that really makes any sense here. So we're going to kind of work our way up to that. I'll probably talk about it like the last week because I think it's super fun. And that's interesting stuff you can do in Python. So we're going to get to functions. So we've been using functions all along. So let me fire up PyCharm here. We just might not have known they were called functions. Okay? And that's okay. So now we're learning our technical terms here. We start up a new project here. This was chapter 6 for functions. There we go, chapter 6. New project. Let's call this chapter 6. 6. Functions. Create the project. I did get a new laptop. I'm super excited. But I did not install any of my programming tools on it because I installed my games first. So, priorities, right? This laptop could not play any of the games, and I was so sad. So I got Diablo 4 installed. I got Baldur's Gate, a couple other ones. I didn't actually play Baldur's Gate yet. My son's been playing it, but this laptop wouldn't run it at all. So I missed out on the initial hype when it first came out, but I think it's okay. Really excited. I'm going to try not to play it until I get the grading done because that should happen. So I'll be working on that here, but that's the goal. Anyway, so print is a function. Like Happy Monday is a function. You give it something here, you give it a string or a bunch of strings, or you got some options here, and it does something for us. Right? This is a built-in function. We've been using it a lot. If we wanted to use random, we could import random. We said, hey, let's get a random number. So how do we say for number in range 5? I'm going to print random dot next int. We want 1 to 69 here. Or no, next, random dot randint. There we go. Randint. Never remember. And you can be this is terrible variable names. That's fine. So how about we print or Powerball numbers are. And then we want to change this print right to an end to nothing, or maybe a space here to space separate them here. And then at the end of that, we want to print the Powerball number is, and that is random.randint, I think 1 to 26, I want to say. So we'll give you the special lotto numbers that obviously give you a good chance of winning the Powerball here, and you can go waste your money if you want. We'll get more into this later because I like Powerball as an assignment. Being able to let people pretend to spend their money and lose money is very satisfying, and then they don't have to lose their actual money. So we'll get into that. But randint is a function. it gives us a value. So print doesn't give us any values, right? We never say, hey, something equals print. But we could say something would equal random randint here, or we can just use it in some output because it returns a value to us. It gives us something back, right? And we've done other things like taking strings uppercase and lowercase, right? Maybe we said, we'll play again equals a y, and while play again. Now, again, we wanted this as upper here, or maybe lower. I like lowercase, right? Why not lowercase? Dot lower is equal to a y. We want to do something here, right? So play again dot lower gives us a lowercase version of a string, right? Now notice with randint, you have to give it some values. These are arguments. Lower doesn't need any arguments. You don't have to tell it anything to get a lowercase number. Print, technically you can just say print here. You don't need to give it anything. You can, so these are optional arguments. We'll get to that later. But we've been using lots of functions, right, all along here. And eventually, my play again is equal to an input of to play again, right, y/no, y or no, yes or no, right? And if we wanted to be fancy, right, we could just take the first character of that in case they typed out the word yes, right? Remember, we could get, say, index of 0 of that. Remember, you can take individual indexes of strings. Sure. They probably type in it, if it's not a y, anything other than a y will just end, which is probably safe, right? So sure, so we've been using functions. Now, the fun thing now is we get to write our own functions here. And there's a really funny, let me see if I can find it. Oh, goodness, Python coding. I think it's Python coding. It's their platform. Why am I terrible at this? All right, Twitter, Python coding. I think it's Python coding. Might be it. They had a really funny tweet here. Nope. Something about Python. On soft Python? Oh, this one. CL coding? Why? No. Goodness gracious. Okay, there was a funny tweet, and I couldn't find it. I meant to save it for you guys, but that's okay. About how all the other languages have different ways of defining functions, and Python is completely different than all the other popular languages because they're special. It's one of those Winnie the Pooh face ones. You guys love memes, right? Okay, I'll find it for you later. I'll show it to you. So what we get to do is we get to write our own functions. So if we want to do something more than once, right? If we want to avoid having a repeated code and feel bad about ourselves, we can write a function for it. So I can say, hey, I want to define a function called Happy Monday. Monday, and then a set of parentheses, and then a colon. So I'm making a function. I'm defining this function called Happy Monday. Here's the list of arguments. It doesn't need any arguments, doesn't need any parameters here. And then a colon. Everything inside of here now will happen when I call Happy Monday. So I can say, hey, print Happy Monday, and then print, we're going to need more coffee. Right? And then in the rest of my code, what I can do. So you get these yellow lines a lot. The Python standards are very particular. So it says it's expected 2 blank lines, not 1. The yellow lines are just warnings. You don't need to make them go away, but they make me happy when I make them go away. Yeah?
So when we import one, pretty much all the ones that we define functions. Is that okay?
So when we import random, Python goes out and essentially reads the random file, and all of that is now loaded for us to use. So we've now have all these random functions like randint and range and choice and everything. Yeah, so it's all the functions defined in the random module are now are available to us.
So if you go and open the random file,
yep.
You have to select now, define, randint,
yeah, I think we looked at that file before. We can go find it again because it's fun. Let's see if we open in Explorer in our virtual environment. And then I think it's library. No, must be scripts. Scripts? No. Oh, is it in the library? Somewhere in here. I forget where it is. It might just be my Python install. We could find it. I don't remember where it is offhand. I can go find it for you later. Now I want to find it. Now I'm wondering, is it program files, Python? Nope, program files, not x86. Python, don't. Okay, so it must be my C users folder. Hang on, C users, data, local. No? What folder is it in? Roaming? It's not in roaming, right? Python. Goodness gracious, it's somewhere here. Local low? I don't think it's low. Python? All right, hey, we can find it. Settings, project interpreter, show all. Where's my other interpreter? It's in scripts. Where's my other system interpreter? Ah, right here. So app data local. Oh, programs Python. I was so close. Programs Python. Python's re10. And here's the library. Now here's the random file. There we go. So here's random. We can open this one here if we want. And then we can find all the good stuff inside of random. Maybe. Did it open it? Ah, here's random. Okay, yep. So in here now we can find randint of A and B, returns rand range of A plus B plus 1, A and B plus 1. We can find rand range, I think it was up here, right? It says, hey, here's your start. You can give it a stop if you want. It's optional. And again, we'll get to all these things a little bit here. And this is what it's actually doing here when it tries to give you a random number. Most of it's not super readable yet, but we'll get there. Yep, so we can see it all. That was fun. So happy Monday then. So instead of saying print happy Monday, I can say, hey, I want to use the happy Monday function. I just say happy Monday. So when I run this now, we'll get the first happy Monday, right? Because we just printed happy Monday. And then we'll get happy Monday, we're going to need more coffee because we called the happy Monday function. And then we get the rest of our Powerball things here. And again, we're not checking for duplicates. So don't, this, because Powerball works in combination, not permutation. There's no duplicate numbers. So sure, and then you want to play again. No, we want to stop. So we can make our own functions. Now, this is not super useful or helpful right now, but we're just getting started, right? Okay. So other fun things we can do with functions is you can have them accept arguments or parameters. Now, the technical term is a little silly. When you give it a value, this is an argument. When you define it and use it, it's a parameter. So we can say happy day given a day here. So to call the happy day function, you have to give me something I'm going to call day. So I can say happy day given Monday. Now in happy day, I now have a variable called day that has the value of whatever the user gave me. This is my parameter here. I call them arguments everywhere, but technically it's a parameter here. So we can print happy and then the day variable here, and then print going to need some espresso here for happy day. Because why not? And again, it's just a yellow line because it's saying, hey, you should have 2 blank lines in between functions. I like to make them go away because they bother me. It's not going to hurt anything here. Okay, so if you get this one to run, now we're going to need some espresso, happy Monday, right, was the happy day function. So if you want to watch them happen, what's really fun, you come to these line numbers and you can add breakpoints. So instead of run, right, we can debug. We can see the values of our variables. So I'm going to run it in debug mode. And now it says, okay, I'm ready to run line 14, right? In my console, I see it said happy Monday. It did the print here. It's ready to run line 15. This is where we paused. So before it said, usually we're going to use the step over. But step over will step over our function. A function will run, but we don't get to see it. So if you want to see what happens in the function, we want to step into, or usually step into my code is a nice filter. It steps just into our code here. So I can say step into my code. And now we see, hey, I was at line 15 here. Now I'm at the happy Monday function at line 5. So Python uses this thing. This is called the call stack. It's essentially like leaving a bookmark. It says, hey, I was at line 15. Leave my bookmark here. Go do this other thing. When that other thing is done, come back to where you left the bookmark. Right, this is how Python tracks everything. It's super cool. We'll talk more about it when we get there. But you can see it's knowing where it left off. So before, when we had done our code, like we started off, hey, Python runs the first line, and then the second line, and then the third line, the fourth line, and it's done. And then we said, oh, well, we can do branching. I can run the first line, and then maybe I run this next block, or maybe I run this other block, depending on if it's an if else, right? And then, but it was still top to bottom. And then we said, well, hey, now I can loop. I don't need to repeat. I don't need to copy paste a bunch of code. I can have a loop that says, okay, let me do a bunch of code and then maybe run it again, and do a bunch of code and maybe run it again, and do a bunch of code and maybe run it again. But it's essentially still line by line by line, top to bottom, with now like a little bit of repeating in here. Functions now let us jump, essentially, right? We can be at any line in our code and jump to somewhere else. And we're leaving those bookmarks so we can come back to that place when we're done. So that's how it tracks it for us, which is really fun. So now I can step and step, and I'll see, hey, I get my commands, and then those done. Now I come back right to where I left off at line 15. Right? I printed my happy Monday, we're going to need more coffee. And I can step again, step into my code. Now I see that day equals Monday. Right? The other cool thing when you're debugging, we can see the value of our variables. So I can see, hey, I have this variable called day. Its value is Monday. And I can do my code here. And now I come back to the next one here. And come on back to the next one, come on back to the next one. Right? So we can watch what happens in our functions, and we can watch as we jump around and do these things. So this function takes an argument here, or it uses a parameter. So Monday is the argument, day is the parameter. Again, I'm just going to call them all arguments. I apologize. Basically, everyone in the world knows that's what it actually means. So rarely is anyone going to say, no, you called it the wrong thing, unless they're really being obnoxious. And some people really like to argue over small things, but generally we should be okay. All right, so that's our function with an argument here. Now these are great, and they let me, right? Now, it's not really not having a repeated code, but it puts a name to what's happening. So if the only thing you do is look at, here's the couple lines here that are running, you don't necessarily need to know all the details about what Happy Day does. If you want, we can go find it here. We can go look it up. Right, sure, I can go. Now, I like this go to option here. Go to implementation will jump me there, and there's a keyboard shortcut for it. This implementation is Control-Alt-B. If you like if you like keyboard shortcuts, you can like click on it and we'll jump you around, because we're going to have a lot of functions as we go. We're going to put a lot of functions in here. And remember, just like when we have variables here, my functions have to be before I use them. I can't put my function down at the bottom, because now Python says, I don't know what a happy day is. Right? Just like with the variable names, I can't say, hey, I have a day equals Monday, and then I can say print day, which is fine, right? But I can't have print another day and then say another day equals Tuesday, right? You can't use a variable before you've told Python about it, before you've declared it to Python, right? Same goes for functions. You have to declare them first, and then Python can use them. Right, so this is just you declare variables and functions before you use them. Now that feels a little funny, right? Because I'm using it here, but I have to write it, right, essentially before I can go and use it. So you have to know what it's going to do here. Let's see, one more. There we go. So you can write it with just the argument here. Why does it not like day 4? Oh, that's fine. Okay, and then we'll go use it later. So same idea here, you just have to declare them first. So we're defining this function first. Then we can go and use it. Now, these functions don't return values, right? Our randint returns a value, right? It gives me something back. So let's look at a function here that can give something back, and we're going to learn another technical term. This is one of my absolute favorite technical terms, is functional decomposition. We're going to take a big problem, we're going to decompose it into smaller and smaller and smaller and smaller pieces using functions. Now, everyone in my family knows I'm a giant nerd, so they're not surprised when, hey, like the Thanksgiving dinner table, I'm like, oh man, I'm so tired of doing all this functional decomposition. They don't even look at me weird anymore. But you guys should try it sometime. It's really funny to see the kind of looks you get when you throw out these crazy technical terms. I find it amusing. So your mileage might vary, but you get some really funny looks when you start talking about functional decomposition to people. So we're going to, let's say, how about our rock, paper, scissors game, right? What if we were to break that into some steps? Can we functionally decompose rock, paper, scissors? Well, what sort of happens in the rock, paper, scissors game? Well, the user has to pick something, the computer has to pick something, and then we see, do we win, lose, or draw, right? Those are kind of the 3 steps that happen. So how about we do that? We can say, hey, my user's throw is equal to get user's throw. That's a function. How about the computer's throw is equal to get computer's throw? Well, that's a function, right? So I know these need to give me a value back because I need to be able to assign it somewhere, right? So I know I'm going to have to give a value back because just like the rand int, I need to give you something, or just like an input, I'm going to give you something. But then for displaying the winner, or display results maybe, I'm going to now say, okay, given the user's throw and the computer's throw, display the results. Did you win, lose, or draw? So you can just kind of quickly look at these 3 steps here and have a feel for what's happening, even if you don't even look at the functions. Right? I can just look at my code and say, oh, okay, I'm going to get the users, get the computers, and then display the results. So it sort of lets us put a name to what's happening. Right? We're breaking it down. We're doing this functional decomposition. We're breaking it down into smaller and smaller and smaller pieces here so that I can solve, okay, how do I get the user's throw? That is just one small problem I can solve separate from everything else. Now, I'm not going to save any code. I'm not going to have less code in my program now, right? I'm not removing that repeated code so I feel better about myself, but I'm putting a name to what's happening. And that's a huge value of functions, is it just puts a name to what the code is doing. Because that's for people. The code is for people to read. Yeah.
Suppose we have with 3 parameters. Is there a difference to make it optional in the real argument?
Yeah. Yeah, we'll look at that. That's the next, like, once we've done the basics of functions, we'll probably get to that on Wednesday. Yep. All right, so now I need to go and write these functions, right? So I'll just come up. Usually people put the functions at the top. Again, it doesn't really matter too much as long as you define them beforehand. But it's a little weird to have like code and functions and code and functions and code and functions. Just a convention. So usually we put them all at the top. So let's define, this is get user's throw. Right, and eventually we'll return the user's throw. So I need now to ask the user to enter something. Right, so I'm going to have I don't know, user's throw is equal to an input of enter rock, paper, or scissors. Right, and now I want to validate. I want to make sure that they give me something good. So I can say while user's throw. Now we got a couple options here. I like the list idea. That's a nice little shortcut here. So I can have a list of, this is, I don't know, options is a list of, and maybe even a tuple, right? This is rock, this is paper, this is scissors, right? While user's throw is not in the options list, let's ask them again. Now, again, I don't like having the same code twice. So I'm just going to say, hey, the user's throw is an empty string. It's still a string. It's not one of the options here. And I'll keep on asking for input here. Eventually, when I'm done now, right, when this is no longer true, when their throw is in the list of available options here, again, I might want to take this lowercase as well. Let's lowercase their input, just in case they had capital letters. When I'm done, I'm going to use a new keyword. I'm going to use the return keyword. I'm going to return user's throw. So return is the keyword that says, when this function's done, give a value back. So eventually, I will give back the value of user's throw here. Now, this is just my name for it, which is great. Fine. So now I can assign whatever I get back from this function, I'm going to call the user's throw over here. These variable names don't need to match. Right? This could be A. And Python won't care. Right? That's okay. The variable names are for people. So generally, I use nice verbose variable names. It's the user's throw both places. So it gives us some warnings. We'll talk about that later. Don't worry about it yet. But now this is my user's throw, and it's even validated, which is nice, right? You can't give me a value that doesn't exist. Okay? So we've got that. Now how about getting the computer's throw? Fine, get computer's throw. Well, with the computer's throw, it should be random. Right? We should pick a random number, 1, 2, or 3, or 0, 1, or 2, or whatever we want to do, right? And then assign it a particular value. So let's have the, I don't know, random number is random.randint of 1 to 3. Sure. And then we can say, hey, here's my computer's throw. Computer's throw is equal to nothing to start. And then if my random number, actually, we don't even need that. Sorry, we can skip that. So if random number is equal to 1, we'll say computer's throw is equal to rock. elif, my random number is equal to a 2, my computer's throw is equal to paper. And then I don't need an elif again, because if it's not a 1, it's not a 2, I know it's a 3, so it's just an else here. My computer's throw is equal to scissors. When I'm done, I can return computer's throw. Again, it's giving you that warning, it's the shadowing thing, don't worry too much about it here. So generally, I like when functions have a return at the bottom. Yeah. So return will give a value back to whoever asked for the function to run. So like when we said something equals get computer's throw, we want to assign the value, whatever we get back, to a variable called computer's throw. If you don't return, you don't get anything back, there's no value. So like our happy days, just prints, there's no return value. So the function can give us a value for us to use later. So functions don't have to give value back. They can just run some code and be done. So like the print function doesn't give any values. We never said, hey, test equals print here, right? We never used a variable of the value of print because it doesn't do anything. And it's even telling us, hey, function print doesn't return anything. We get a warning here. PyCharm's like, hey, you did the dumb thing here. You're never going to have a value because print doesn't do that. But random number does do that. So like if we said, hey, number is random.randint 1 to 20, right? Randint will give you a value back, and we can assign that to number. So it's telling us, hey, you can go do this thing. Now, you get a little bit of information here that's saying, hey, it's going to give you an integer. So this define randint, given self, don't worry about that. A and B is our integers, and this little arrow, I'm pointing at my screen like you can see that. This little arrow here saying it's going to give you back an integer. This is some cool notation we get with Python 3. Some people have started switching to use it. We're not quite there yet, I don't think. So we'll talk about it later, probably near the end, what that other notation looks like. Because it's not widely used everywhere yet, I find it confusing. So I try not to use it. We'll get there eventually. But it's saying, hey, this will give you back an integer. It's an int. We know randint will do that. So I can say, okay, I know number is going to be an integer. Sure, that'll work here. So in our functions then, I like returning at the end, but you can have more than one return statement. Right? You can say instead of computer's throw equals rock, you can say, hey, let's return rock. You can put a return anywhere you want in your code here. Once you hit a return statement, your function's done. Stops. You can't have code after it here, like print function will never get here. Right? It's even telling me right off the bat here that this code is unreachable. Once a return statement runs, the function stops. So it doesn't run any more lines after that. So putting code after this return statement will never run here. So and PyCharm's even telling us, hey dummy, you can't get here. So it's just an option. So some people like multiple returns. Now for something small, not paper, scissors, right? For something small like this, I think returns are fine here. Generally, I like just a single return at the bottom. Again, I just like to be able to read the code and have it flow and not, okay, in the middle of the function, it returned a value, and then there's a bunch of other code that I don't know what it's doing, right? Like, it gets to be a little confusing sometimes. So this is small enough. Either is probably fine. I'm going to leave these commented out here. That's an option here. But, excuse me, again, either way is okay. It'll work for you one way or the other. So these functions return values, right? So we can assign them to variables. I can say, okay, run this function, whatever I get back, assign to user's throw. Run this function, whatever I get back, assign to computer's throw. And then display results. Let's go add a display results function. So display results, now this one needs arguments, just like our function for happy day needed an argument. So I'm going to say, this is my display results, given the user's throw, comma, the computer's throw. So to call this function, you have to give it two values, the user's throw and the computer's throw. Now again, this was a quick check, right? You either win, you lose, or you draw. So draw is the fastest to check. If the user's throw is equal to the computer's throw, print draw. That one's fast. The next ones are a little trickier. Right? So elif, now I want win, because I want the win condition. That's probably easy to check. If my user's throw is equal to rock, and the computer's throw is equal to scissors, right? If I'm rock and they're scissors, I win. Or sorry, I need a slash here so I can go down the line. If the user's throw is equal to paper and the computer's throw is equal to rock, then I win. Or if my user's throw is equal to scissors and the computer's throw is equal to paper, I win. So this and this, or this and this, or this and this are true, right? It's a lot of those logical operators happening here. But this and this, and I know order of operations. I know that that ands happen first. Because it might be a little silly to say, hey, it's computers throw scissors or users throw paper, and then and those with other, like, it can get really weird really quick if you don't know the order of operations. So if you want to throw some parentheses in, go for it. They're redundant, but the computer doesn't care, right? Python doesn't care about redundancy. It's nice for people to visually see, okay, hey, this is the pairing, this and this, or this and this, or this and this. Like, it's just useful here to have them, yeah.
What is the backslash for?
It tells Python that I continued on to the next line. So usually when you have white space, Python is like, oh, your line of code is done. Because I didn't want this all in one big long line. We could write them as different elifs if we wanted. So this is a single Boolean expression right now because I'm using ands and ors. If you wanted, you could say elif rock and scissors, elif paper and rock, elif scissors and paper. I don't have to type a bunch of elifs, right? I want to just put it in here as a single elif. This is true. Again, just a style preference. It'll do the exact same thing as 3 different elifs, right? I'm just going to put them all here and say or. So if that's true, I'm going to print player wins. And then I don't need to check anything else because if I didn't draw and I didn't win, I must have lost, right? Player loses. Loses. That's it. So that's my rock, paper, scissors game functionally decomposed into get users throw, get computers throw, display results. That's it. And then I can loop this all with the play again. So we can run this real quick and see if it actually works. All right, you want to play rock, paper, scissors? Rock, that's right. We always play rock. Player wins. Play again? Yes. Rock. Player wins. Play again? Yes. Rock. Oh, we drew this time. Play again? Yes. Rock. We win. See, rock is the best. We win. Yes. Play again. Rock. We drew. Yes. Are we ever going to lose? Oh, there we go. Okay, we finally lost. So eventually we'll hit one of those conditions, right? The odds of that kind of work in our favor. Okay. Now, all of you folks are really good at statistics, right? If you're into data science, you're probably interested in statistics. So there's the chance of never losing is functionally 0. There technically is a chance of it, right? It's essentially 0 as we go, right? The more we play, the more chance we have, a third and a third and a third and a third. Is never actually 0, but it's basically 0. So if you ever want to confuse somebody, you can tell them you have a winning strategy for a casino, right? Because there's a game called roulette that you bet on. You can bet on specific numbers, you can bet on black, you can bet on red, you can bet on the green 0 or the green double 0, this sort of thing. So to always win money, guaranteed, I promise you will always win money, is you bet $1, and if you win, you won your $1. If you lose, you double your bet, right? Bet $1. If you lose, your next bet is $2. So if you win, you get back $4. You've bet 3, you won your $1 back. If you lose, double your bet. Bet $4. If you win, you double your bet. You make $8 back. You've bet 7, right? 4 plus 2 plus 1. If you lose, double your bet. If you lose, double your bet. You're guaranteed to not lose money, right? We understand that works because it's never actually 0. Eventually you'll win. The problem is you probably run out of money. And eventually the casino says, no, you can't wager this much. Right? They love taking your money. But at some point, if you keep doubling, right? 4, 8, 16, 32, 64, 128, 256, 512, 1024, they probably let you bet that. 2048, maybe, like 4096, 8192. These numbers are in my head for stupid reasons. Right? Don't memorize them. But sure, eventually, like, you probably can't bet $16,000 and whatever change on roulette because you don't have it in your pocket just to win a single $1. But if you did, you could always win money at roulette, right? You just got to find a casino that's going to let you bet infinite amounts of money because you're probably not going to lose 32 times in a row. But if you did, you're at 2 billion, right? When we looked at our numbers here, that's our regular integer, 2 billion. No casino is going to let you bet 2 billion. And you could possibly lose 32 times in a row. It's just really, 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 really unlikely, like, right? So that's just a silly stats thing. I don't know how we ended up in that rabbit hole. Oh, the why do we keep winning with rock? I'm sorry? Yeah, I mean, it's foolproof. If you have infinite money and the casino lets you bet infinite money, you can't lose. So that's your fun fact. I don't recommend that to people though. That's probably a good way to lose a lot of money really quick. So blackjack is actually the best possible game you can play statistics wise, because there's things you can do to increase your odds of winning. You're still likely to lose, but you can do things to increase your odds of winning here. But those things tend to get you kicked out of casinos too. So they don't. Turns out they don't like losing money. Who knew? Right? Did I tell you about the gamblers and slot machines and the Russian mob? Okay. Yeah. Once they're like, hey, we're losing money on slot machines, they knew something was wrong because slot machines don't lose money. That's just a fact, right? They don't lose the casino money. If they did, they wouldn't put them in. What? Slot machines. You put a coin in, you pull a lever, push a button, and it generates 3 random things, and you're like, hey, it spins, and you get a chance of winning. Right? They're really depressing, actually. To like watch people sit and play slot machines is really sad. Like, they don't even look like they're having fun. They're just like zombies almost, and the people who are playing are least likely to have the money to afford to be able to go and like spend $20 and have some fun. Like okay, that's a whole other story. All right.
Earning money on the machines, like earning the money that other people lost.
So people do win, but overall the casino makes money off of it, just like the lottery. The state makes money off of it. There's billboards that say, "Hey, we've gotten billions of dollars for schools thanks to everyone playing the lottery." We all know it's designed for the state to make money, right? They're not even like lying to you. They're like, we're taking your money. Some people win some of it back, but they keep part of it because it makes them money, right? That's how the system works. And the state used to not have the lottery, and then they decided, well, people keep going to Ohio to buy lottery tickets, and Ohio's making the money. Michigan should make that money. They're like, oh, okay, let's do lottery in Michigan, and then they legalized the lottery in Michigan because it makes them money. Most of the people who play the lottery can't afford to play it. It's a tax on the poor people who can't afford these things, and it's awful. But again, that's a whole other story. We'll get into that when we play Powerball, which is fun. Yeah, sure. I'm getting sad. I'm sorry. Let's get off the sad stuff. All right. So our functions, right? We did some functional decomposition. We broke down rock, paper, scissors here into smaller pieces with functions. We didn't save any code, right? One of the goals of functions is to avoid repeated code. So I don't have to do the same thing a bunch of times over and over and over. I can just say, hey, do this function, please. That's probably a good benefit, one of the best benefits of it, right? Because if you have the same code in your program twice, you should feel bad about yourself. We don't want to feel bad about ourselves. We want to feel clever. Sure. But putting a name to what's happening, breaking a problem down into smaller pieces, is a huge benefit as well. This is awesome. So we've quickly, at a glance now, you can see these 3 things and just get a feel for what's happening. Now, you might also see some people, because why write 3 lines of code when you can write 1? You might see people say, hey, let's display results of the get users throw, comma, of the get computers throw. Right? You can put a function that will return a parameter, return an argument in place of that argument. So display results, you have to give it a user's throw and a computer's throw. We have to do that. So I can give it a function that will return a value here. Right? So this is 1 line instead of 3. Some people like that. Because we're not using user's throw anywhere other than display results. So I don't need the value to be stored anywhere. I don't need to keep it around. So I could just do that here. Now, this might be a little bit more awkward to read, but you'll probably see this sort of thing a lot. And we've done this, like we said, hey, with play again, where's the lowercase? I thought I did a lowercasing somewhere. Didn't I do that somewhere? Right here, right? I said, get the input and then lowercase it, right? Here's a function and then do something with it in 1 line, rather than saying, hey, users throw equals users throw dot lower, right? This is the 2-line version This is the, oh goodness gracious, this is the one-line version. They do the exact same thing, right? It's just this is really just a style preference at this point here. Do you want to just essentially tack it on to the end, or do you want to do it as a separate line? Just a personal preference, right? Let me leave that commented out, right? Either way is okay. So does the same thing here. We're just saying, hey, grab the value, kind of tack it on into this call for display results. And here, I'll leave these ones commented out. So this is the more verbose way, and this is the shortcut way, or shorter way. That's all. So we got some preferences here. So you were asking about functions that have more than one argument, right? Like randint takes two arguments, an A and a B. Where's the start, where's the end? We can do that sort of thing. So how about a function here, like, so let's put it in here. Define if you're happy and you know it. So if you're happy and you know it, you need an action like clap your hands or stomp your feet or shout hooray, right? And then you also need the verse. Is this the first verse, the second verse, or the third verse? Right, because they're different here. So if you are happy, that's spelled better, but I can't put apostrophes in there. If you are happy, that just sounds awful, but that's fine. So here's our function. You have to give it two things, right? I'm just going to comma separate. Here's the things I want. I need an action and they need a verse. So if my verse is less than 3, I'm going to print if you're happy and you know it, action, whatever that action is, right? Otherwise, I'm going to print if you're happy and you know it and you really want to show it. Do that action, right? So I can call this function then, put it down here, given clap your hands, and then we need the verse number. So let's do a loop here. So let's say for verse in range, let's go 1 to 3, but remember it stops at 3, so I want 1 to 4. So I get 1, 2, and 3. Right, with our ranges here, clap your hands, and then we'll give it the verse. Now we get 1, 2, and 3. Right? So now I can use my function here and not have to print out those same things every time, or not have to have this same sort of logic every time, or however I want to do it. Right? So I can have a function that takes more than one argument here. Here's the, and it's helpful. Now it's trying to tell me, hey, this first thing is an action. Now the funny thing in Python is we don't get to tell people, hey, you have to give me something that is a string. Right? We're hoping people give us a string, and that's what some of that notation lets us do later. But I can say display results of 1 and 2, and say, hey, the user throws 1, computer throws 2. The code's going to run. Right? Now, hopefully it doesn't crash, and I think our code will be okay, right? Because 1 does not equal rock, 2 does not equal scissors, like this sort of thing here. Let's give it a shot. Let's see if it runs. Rock, no, we don't want to play again. So with 1 and 2, the player loses because that was our default, our else case, right? You can't, or we didn't draw because the numbers weren't the same. We didn't win because none of us were strings, right? These can't be true if I give it a 1 and a 2. So I lose. But nothing prevents us from giving weird values to these things here, right? I don't have to give it the value of rock, the value of paper, the value of scissors, right? Nothing stops me from doing that. So because Python is typeless, you can give it any type of value. You can give it floats, you can give it ints, you can give it strings, you can give it all sorts of weird stuff here that might not fit. So there's a couple things we can do. We'll get into that later. Getting into that right now is a little bit of a headache. How do we check for those sorts of things? Or how do we say I want to specify specific types? Gets to be a little funny. All right? So you can do weird things. Give weird values to functions. You just got to be careful with it. That's all. So if we were to do something like try and get a substring, or like get a slice, get a single character out of a string here, it's going to crash. Right? Like if I wanted to say, hey, my letter is user's throw of 0. This is meaningless, but it'll work when it strings. So rock is fine. Don't play again. But now it crashes, and I get type int object is not subscriptable. This is technically a subscript. And that's our term here. And it says, hey, it crashed at line 43 in display results of user's throw from line 99 in display results 1 of 2. So remember how I said when we call functions, it goes on that call stack? Python says, here's my bookmark. when you get an error, it prints out the entire call stack in reverse order. So I get, this is where it was currently running, right? So my lowest down line is, hey, it crashed in line 43 in display results. I got there from line 99 when I called display results of 1 and 2. Right? So reading errors gets to be a little bit trickier when we start using functions. Right? So it's basically you want to look at the lowest down one to see what caused the error, but then, hey, where did they get this weird value? Oh, maybe I got the weird value from line 99 here. So you kind of have to follow those spaces here. And that's why it gives you the entire call stack, because that's useful as we investigate what's not working right here. So this crashes if we don't give a string. So technically, if we could give it a list, right, you can take the first value of a list, we can give it a tuple. So mostly. Is that okay to say? You can give it other things that fit this, but it gets awkward, okay? All right, so there's our function there. Let's take a look. How are we doing on Zybooks then? We did functions, we did printing, dynamic typings, functions, math functions. Ooh, function stubs are great. Some of these will save. There's a lot here, my goodness. I think we're going to save some of this for later, though. Yeah. Yeah. So some functions just do something, right? They just run some code, right? Like the print function itself, that we've been using this entire time, just does something. We don't need to get a value back from it. We don't say, hey, give me something back. Functions that give us something back, like we've been using with like randint, right? They give us a value back. They're returning a value to us so I can use it either as a variable or like right in my prints here, right? I'm getting a result back. So if your function needs to give a result back, we need to return something. We use the return keyword to say, give this value back. So in my get users throw, I'm going to return the user's throw so I can assign it to a variable or just use it right in my function here. So I have to use that keyword return. Where's mine here? So like get computer's throw, I can return a value so that whoever uses this function, wherever I'm using it in my code, I can assign it to a variable, or I can use that value in a print immediately or in another function immediately. So without this return word, it doesn't give anything back. This code still runs, we still do these operations, but nothing comes back for us to use later in the program.
Like when the kids are computer throw scissors, don't we already know that?
So we've assigned it here, but I can't use this value here outside of the get computer throw function. So this is where I think we talked a little bit about variables and scope inside of loops. Right? You can have, if you declare a variable inside a loop, it doesn't exist outside the loop. It goes away. So these I've got the same names lots of places here, but yeah. So if you want to hang on to that value when the function's done, we need to assign it somewhere so we can keep it.
So when you're returning the target, you're pretty much creating this object out of the loop, right?
It gets created in the function and then it gets given back. So it still exists. Yeah.
So we can use it out of the loop.
Yeah. All right. So function stub. So sort of this idea, like when we did the get users throw, get computers throw, display results, you can create function stubs just so they exist but don't do anything. So if we wanted to make a more interesting problem here of how do I take a big problem and break it down into smaller and smaller and smaller steps, we can write these function stubs as a way to sort of brainstorm, think through the process, and then because they're stubbed, I can actually run my program a little bit at a time. So if we were to come up with another set of functions, another problem to solve, like what if we had, oh man, I'm trying to think of a good one. How about we have a function for get the weather, right? Sure, so we're going to define a function, get weather. So we can do lots of different things. So yeah, if we wanted to return the temperature specifically, we could do that. So right now we'd be able to say, hey, let's return 70. I've stubbed this function out now so that it's always returning one value, but it will exist and be available in Python. So I should put my functions up top here, sorry. let's see. So I have a get weather function that's always going to return 70. So later in my program, right, I can say, hey, if get weather is greater than, I don't know, 65, we say, bring your sunscreen. Put on sunscreen, or I don't know, you don't need a jacket, wear a shirt, t-shirt, right? Else, print, you need a jacket, right? I don't need to have this working yet. I can just have a stub of it here that exists so the program will run, and I can test the rest of it. I can come back later and figure out how get weather works, right? Maybe we even want to like, hey, let's go get the weather from the internet. There's really cool things you can do in Python. You can send web requests out to places online. We'll get more into it later, but you can get data online through an API and then use that data in your program. That's where it's really fun, right? I'm going to get live data from somewhere online and do something with it. My program will interact with it directly, which is really cool. So for now, we don't. Right? Maybe we just pick a random number. Maybe we just pick 70, but we can do more things with get weather later. Right? We can solve that problem later. We'll come back to do get weather data from online. Right? We can come back and do that later. So we've stubbed the function out so it exists. Right? Sure. So maybe we even have like 70 and sunny, right? We can return, remember you can, we haven't done this yet, sorry. So you can return more than one value as a tuple. So the rule with return is you can only return one thing. Remember, tuples are a collection. A tuple is one thing. It just happens to hold multiple things. So you can return a tuple of items, and you don't need to give it the parentheses. Python will do the parentheses for you if you just comma separate. It's like, hey, it's redundant.
That's immutable.
Yes, so tuples are going to be immutable. The tuple itself is, but then we have the values, we can work with them. It gets a little bit silly. I don't know if we want to change these things or not, but once we get the values back, we can change them on our side. We're just not changing them in the function. Yeah, it gets a little weird. So here's the get weather. Now I can't just say it's less than 65, so I need, let's say, how about temp and, what is it, like, what is that called if it's cloudy or sunny, or just description, maybe? Description equals get weather. We've done multiple values before, right? Getting something back from a function. Have we done this? We just kind of separate. I think we did with enumerate. That might have been the only one we did. You can get two values back. You get the value and the index. So now I can say, okay, is the temp greater than 65, right? And then I don't know what, if my description is equal to sunny, Sunday, sunny, print, put on sunscreen. I don't know. So we can do whatever we want here with it. So you can get more than one value if you want. Eventually we can get the real weather off of an API somewhere. We'll get to that later. That one's a little bit trickier. We can get there. But we can do fun things. You don't have to have them all defined all at once. That's sort of the idea. Was just, let's give it a value so it exists. I can test the rest of my code based on that and make sure it works, and then come back to that big problem later, right? What if we wanted to build like a little program for making a shopping list? We could do something like that. So maybe we said, hey, let's more items to buy equals a y, right? And then while we have more items to buy equals a y, let's get an item, right? So how about item is get item? Now, I need to be storing these probably in a list somewhere, right? So let's keep a list of items here. Here's a list. To get an item, now I want to make sure I don't have duplicates, right? If I already have it on my shopping list, I don't want to get it again. So I'm going to give it the items list here, list of items, when I call get item. So eventually let's write a function for get item given an items list, right? And actually, if we just give it the list, we can interact with it here, which is nice. So we can get some item off the list. Because if you give it a list, you can add to it. Lists are mutable. We can add to it. We can subtract from it. We can do those things. So, and then we'll ask, do you have more to buy? More to buy is an input of you have more items goodbye, Y or no, right? So get items, if we're not returning a value, if we're not assigning it somewhere, doesn't need to have a lot in here. So you can use this keyword pass that tells Python, hey, I'll come back to this later. If you don't have pass in here, it's going to be upset with us here. And now this items down here says an indent expected. It's like, hey, I'm missing some code. So the pass keyword is essentially a placeholder. Or I know I'll put something in here later. So I've stubbed the get item function here. Doesn't do anything yet, but we can essentially do our quick little loop here for adding more items to our grocery list. Right? We can go add some items, add some items, add some items, add some items. Right? And eventually, once we're done with our list here, then we can go buy them. Right? Sure. Now we can do another thing. We could have maybe buy item that would take it off our list, or we got some options here. Things we could do with our program, but you can have a stub of a function that's just there. We can come back to it later. So they had a couple examples for stubs too, which were fun. And it does use incremental development. So, hey, if I want to have steps to feet and steps to calories, I'm going to come back to that one later because, right, I'm just going to do the first one. Right, we'll come back and figure it later. Or you could print a fix me or whatever you want here. You got lots of options. This raise, you can do that. This is probably the most proper way, but we don't know what these mean yet, so I skip it. We'll come back to that later. So to get the coordinates, you say get points, get 3 points, and then you can get the perimeter length of your coordinates. Sure, we can come back and figure out how to do that later, right? Let's just define this is what I want here in my program. We'll come back later and get to it. Like, hey, get the user's number, compute the average. We can write some functions, stub them out so the program runs. User's number could always be 1 until we figure out what we want to do here. We got some choices. So you can do all sorts of fun things with your functions, just sort of brainstorming. We can put them out there and come back to them later and fix it. Probably feels a little funny, but yeah, okay. We'll get to the object part later. Scope we'll talk about on Wednesday as well. Parameter. Okay, so I think we're okay to save the rest of that for Wednesday. This will get us through for lab today. We'll just write some practice functions that don't do a whole lot, but they get us started here. Okay? All right, awesome. Questions, thoughts, concerns? You okay? All right, so we'll break for now. We'll come back for lab at 2 o'clock, and we'll go from there. All right, thanks, folks.